Hi guys, so now that you know the definitions that we need to use when talking about polynomials, we can jump right into polynomial addition and subtraction. So let's start with the easiest operation, addition, okay? We're going to take two polynomials and we're going to add them together. And when you do that, these are the 4 steps that you'll follow. The first of which is you find the like terms. Remember, same variable, same degree. Second is add coefficients of those like terms. The third is the degree will stay the same for each of your like terms. And then finally, you write the final answer in descending order of degree. So that just means from highest degree to lowest degree. And that was a lot of words, so let's just do an example because I find that math is much easier to understand when you actually just do many, many examples over and over and over again. So let's take a look at an example. Here I have quantity 5z to the 8th minus 4z cubed plus 6 plus the quantity 6z cubed minus 2z to the 8th. Now the reason that I chose this example was because I pulled it right from our previous slide, so it should look sort of familiar, and that first step should be pretty easy for us. So the first thing we're going to do is find like terms. That just means, again, same variable, same degree, and we know from our previous slide that we actually have 2 sets of like terms here. The first of which is 5z to the 8th and negative 2z to the 8th, right? Because again, same variable z, same degree, that z is being raised to the 8th power. And we have one more set of like terms, negative 4z cubed and 6z cubed. Again, same variable z, same degree 3. And then we do have this 6 that's just going to be kind of by himself. He's got no like term to be paired up with, but that's okay. He doesn't have to have. Not all of your terms are going to be paired up with like terms. All right? Now that we have identified our like terms, what we're going to do is we're going to look at those like terms and we're going to add the coefficients. So here, all I've done is I've rewritten this. I've combined the polynomials so the parentheses are gone, and I've put my sets of like terms next to each other in the same color just to make it a little bit more visual for you, okay? So our first set of like terms, let's look at those coefficients. We had 5z to the 8th and negative 2z to the 8th, right? The coefficient's just the number, right? So we have 5 and negative 2. So we need to add those coefficients together. Let me say it like this. What is 5z to the 8th plus negative 2z to the 8th, right? How many z to the 8th do I have? So another way to think about that, 5z to the 8th minus 2z to the 8th, that leaves me with 3z to the 8th, okay? Notice that this is really important. The degree stays the same, guys. We're just dealing with z to the 8ths with those terms, okay? We're not adding those degrees together. We're not subtracting those degrees together. The degrees simply stay the same because we're taking 5z to the 8th and we're adding negative 2z to the 8th. So our answer, we're going to be left with some amount of z to the 8th. Okay, so your degrees stay the same when you add and subtract like terms. All right. Now we need to do that same thing to our next set of like terms, negative 4z cubed and positive 6z cubed. So let's look at the coefficients, right? Because we need to add the coefficients. That's our second step. So we have negative 4 and 6. Now we're going to say the same thing to ourselves. What's negative 4z cubes plus 6z cubes? So negative 4 plus 6, or another way to think about that is 6 minus 4, right? That leaves us with positive 2z cubed left, right? Because 6 minus 4 is a positive 2. And again, so important, our degrees always stay the same when we're combining like terms, okay? And then finally, we just had this little 6 hanging out over here. We have nothing to combine him with, so he just hangs out at the end over there. The last step, of course, is to make sure that we have written our final answer in descending order. That just means highest to lowest order of degree. So if you look at your degrees here, okay, well, our z to the 8th is going to come first because 8 is the highest degree. Then our next highest degree was 3, the z cubed term. And our lowest degree here was, remember, when there's just a number, it's like we have the variable being raised to the 0 power, because anything to the 0 power is just 1. Okay, so it's like our lowest degree here is 0. So we went from highest, 8, to our next highest, which was 3, to our lowest, which was 0. So you always want to make sure your final answer is written, your polynomial is written in order of highest degree to lowest degree, okay? So your highest variable should come first, and then it should just move down to the next lowest, to the next lowest, to the next lowest. to next highest, as you go down until you get to the lowest degree term at the end. All right, so that is polynomial addition. Not so bad, right? When you see it in order, it's just basically combining like terms. So now let's look at polynomial subtraction, which is very similar to addition with just one extra step. Polynomial subtraction is just like polynomial addition. There's just one extra step within it, okay? So the first thing you need to do, that extra step, is you're going to make this addition by distributing the negative sign. Everything else is exactly the same as what we did for polynomial addition. We find like terms, add the coefficients, degrees stay the same, and we write our final answer in descending order. So how do we turn this into an addition? Let's look at our example here, okay? Here it is. All right, so we have quantity 5y cubed plus 7y minus 3 minus quantity 4y squared minus 2y minus 3. Whenever you see a negative sign, you guys, and parentheses coming right after it, it should scream distribute at you. You need to take this negative sign and you need to distribute it through to each of the terms within the parentheses, okay? So that is our first step. Once we do that, we're going to deal with it just like we did addition, all right? So let's do that. So we're going to take the negative sign and distribute it to the negative 4y squared, to the negative 2y, and to the negative 3, all right? And this little negative sign just means it's like there's like a little negative 1 right here being multiplied by each of those terms. So once we distribute it, this is what we get. Our whole first piece stays the same. Okay, we're not doing anything to this first piece. It stays identical. But when we distribute that negative 1 to 4y squared, we get negative 4y squared, right? When we distribute it to negative 1 times negative 2y, well, those negatives now cancel, so we're left with positive 2y. And when we distribute that negative 1 times the negative 3, again, the negatives will cancel. 1 times 3 is just 3, so we get a positive 3. All right, so now that we've distributed everything, we've gotten rid of the parentheses, we've distributed our negative sign, we can deal with this now exactly like we did with polynomial addition. So we're going to now find the like terms. And I like to start with the term that's got the highest degree and sort of work my way back there. Work my way down. So my 5y cubed, I look and I say, okay, is there any other term that's got a y cubed in it? No y cubed. So there's nothing to combine that with. All right. So I did my y cubed. Now I'm going to look at my y squared. And you don't have to go in this order. This is the way I prefer. You might just see the like terms and just go from there. That's fine. I'm going to look, see if there's a y squared, no other y squared, no y squared, no y squared, no y squared, no y squared. So there's nothing to combine the y squareds with. So now I'm going to look at the y's. And yes, I do find some like terms there, right? Same variable y. That y is being raised to that little invisible first power, okay? So we can combine those. Those are like terms. And then, of course, the numbers. It's like there's that invisible y to the 0 power, right? Anything to the 0 power is just 1. So it's like those 3's are being multiplied by 1. So we have two sets of like terms here. Same variable, same degree, right? 7y and 2y. And then, of course, negative 3 and 3, the numbers we always just combine. Right? Now we're going to add the coefficients of our like terms. So I'm going to start with my 7y and my 2y. If I have 7y's and I add 2y's to them, I get 9y's. All right, here they are. We'll talk about these in a minute. But if I add 7y plus 2y, I wind up with 9y. Okay, right here. And then we're going to move to our next set of like terms. If I take negative 3 and add it to 3, well, that zeroes out. So I'm left with 0. So, I mean, you could write plus 0 at the end, but when mathematicians write things in simplest form, we would get rid of that 0. So we don't actually need to write anything for that number term there. All right, and then, of course, since our lonely little 5y cubed and our negative 4y squared, we had no like terms to combine them with, they just come down and stay the same. All right, so that's where those came from. So when we simplified this polynomial, we wound up with 5y cubed minus 4y squared plus 9y. That is the simplest form we could write this in when we subtracted everything and did our math there. So we need to make sure that our final answer is in descending order of degree. So did we start with our highest degree and move to our lowest degree? Yes, we went 3. We started with degree 3 then we went to degree 2, and then we went to degree 1. It's like there's that little invisible 1 there, right? So this is in descending order. All right, and that is polynomial subtraction. So now on the next slide, you're going to see a few examples that I'd like you just to try on your own. If you have any problems, feel free to reach out. I am here to help, okay? But once you get going with these, you guys, the more you practice, the better you'll get with them. So once you get going with these, they're not so bad. Here are a few practice problems that you guys can try on your own. If you need help, remember to go back into the video, pause, re-listen, re-watch, work through these step by step. And if you have any problems, remember to post in the questions discussion forum and I will get back to you. All right. Thanks, guys. Have fun. Bye.